Hey folks, this is Dan Lattiser coming to you with Chem-125 through Doane University's online program, and today I am here to present Module 8, Interactive Advanced Concepts video presentation, which is ice bending. So I am literally going to come to you straight from the fridge, and we are going to get this underway. This is going to be the second time that this process has occurred for me because I used some non-purified. I used spring water. Ooh, I don't want that to drop. Okay, it's positioned well. I'm going to run back and get that. We're going to make this very fast because this process could be ruined by the changes in temperature. The P signifies right there on the bottle that this is purified water. I did do this with spring water earlier and showed the wife, and she I should have recorded them because it actually worked really, really well. So I'm not going to get too much into explaining what is going on. I'll get into that a little bit after. So right here we have 3 bottles of purified water that have been in the freezer for about between 2 and 3 hours, and the temperatures are about negative 12 to negative 15 Celsius. And right here, if you see this nice up and close, and I am not getting the reaction I was hoping for. Actually, it's very hard to tell, but it is turning into a slush there. It's very hard to see, but there you can see some of the lines that are developing right there. And it's a slushious material. We can go and do a little test pour on it. There you go. It's mostly still in the liquid phase, but as you can see right there, there's a crystalline form at the moment. I don't believe the temperatures are cool enough at this particular point for the other process that I was able to conduct earlier, which is the pour over ice bending. We will, oh, it's actually working. Which is great. I'm very happy that, that this is the case. Oh, there it goes. But this is perfect. This is exactly what we were hoping to see. A little bit on the process here, not to be too into length, but we're looking at the reason why something can maintain a temperature below its freezing point. And what we're looking at here is with the purified water. Well, for one, we want the purified water for a few different reasons, but the reason that it can maintain its liquid state past its particular freezing point is due to the fact that right here I have written down a few reasons. In very pure water, the only way a nucleus is formed is by spontaneous change in the structure of the liquid, or the liquid is exposed to another solid form of ice. And in this case, obviously ice is formed in some way on the outer portions of the bottle, and that has not made contact with the remaining liquid solution or liquid compound of water at that point. But when you expose it to a formed change where you're actually altering the structure of the liquid, it's exposing the remaining liquid to that ice, and allowing for other crystalline structures to grab on and form, and it essentially just increases the rate in which the crystalline structure occurs. Another thing to consider is, just like how people salt roads and things like that, is that impurities and ionic mixes can depress freezing temperatures due to the disturbance in crystal formation, as well as hydrogen bonding. That would be more so on the integration of salt, being that there's covalent bonds trying to occur, and adding salt would throw an ionic mix in there and also disturb the bonding of the hydrogen. So that's kind of what you're looking at there. So the H2O needs nuclei to seed off of ice molecules to form crystals, and in this case we were able to create a disturbance in the liquid structure, which accelerated the crystalline formation. That's pretty much it for me. I do have a link that will be submitted with the video on a tremendous amount of information regarding water and its different temperature states. And it's a really great resource, and I used it to kind of look at before I got into this video. I'm going to make a mess here, but here you go. There's your nice crystalline formation. So this worked out successfully as planned, and please read the little write-up and click on the link for the resources that I used prior to this study. And thank you for watching. And again, I had a really great time during this course, and learned a lot. So I wish everybody well in their future endeavors, and thanks again. All right, you guys take care and have a great weekend.